Hello everyone. I am Mason. I'm a member of Seagrain, a company dedicated to helping restore seagrass ecosystems. Seagrass is an essential part of our environment. It sequesters carbon, it provides habitat and stabilizes sediment and improves water quality. But it's disappearing at an accelerated rate of over 7% per year. But with global initiatives like the United Nations Decade of Ecosystem Restoration and the Global Biodiversity Framework aiming to restore 30% of lost habitat by 2030, there is a lot of efforts going into restoring ecosystems and specifically seagrass. But the problem is that seagrass is extremely labor intensive to restore, and it's full of uncertainty. So how do we address this? Seagrain addresses this problem of gathering enough seeds for large-scale restoration projects by creating a seagrass seed growing facility, which makes the restoration process more efficient and cost-effective. And the market is strong. Current seagrass restoration efforts cost around $700,000 per acre. And if we are able to reduce that cost, then that cost benefit ratio of 1 to 7 for restoring seagrass systems can grow even more. And there's over 100 universities in just the United States researching marine science that might not have access to these seagrass seeds to conduct their own conservation research. And that is another market that we could dive into. And we are currently building our prototype farm and trying to find ways to make it more than just a 3D model. And so our ask is, how do we do this in a time-efficient manner? And what would be the best things for us to add? Should we add water? Should we add fake seeds into our model to make it more realistic? And we would love to hear more about that from the professors later on.
All right, so when it comes to seagrass restoration, there are a few things that really matters to customers. So whether they're environmental organizations, government agencies, or private conservation efforts, they are looking for three key things: cheaper methods of restoration, easy access to seeds, and reliable supply. So based on those three things, our hypothesis is that Seagrains Farm can design a seagrass facility that not only produces and ships seeds consistently, but also does so in a way that is cost effective and scalable. So this would significantly improve how we approach large scale seagrass restoration. Next slide, please. So right now, restoring a single hectare of seagrass costs around $700,000. That's a huge barrier, but we believe Seagrain farms can bring that cost down. So by developing a dedicated facility, we can produce and store seeds in a way that allows them to be shipped without losing more than 15% of their viability. So this ensures that restoration efforts across different locations are both efficient and effective. So to put this into perspective, our first facility at Duke University Marine Lab will have the capacity to produce at least 500,000 seeds per year at full operation. So this output can significantly reduce restoration costs and make large-scale restoration a more viable solution. So with this approach, Seagrain Farms has the potential to transform seagrass restoration, making it more accessible and sustainable for the future. Next slide.
Thank you, Yasir. So here we can see the design layout of the Duke Marine Lab seagrass facility. The facility includes multiple components aimed at maximizing sea growth efficiency. So if you see here, we have two primary tanks which are large and 6 smaller tanks that we can use. So these tanks will be placed on cinder blocks, elevating them to the required height for the ease of operation. In addition to the tanks, the facility also includes an experimental tray for control testing, a display tank to showcase our work to visitors and potential partners. There's a workbench for hands-on processing and research activity, and educational kiosk to help communicate the importance of seagrass conservation, and storage space for maintaining tools. Can we go to the next slide, please? Yeah, so our testing assumptions, we want to evaluate the success of a facility. So in order to do that, we have outlined several key assumptions. Number one is seed production target. So if we can produce more than 500,000 seagrass seeds, the facility would be considered a success. If it is below 500, we would need to modify our approach. Um, Operation cost versus revenue. So if the project will be financially sustainable, if the sale of seeds meets the exceeds the operational cost. However, if the sales of revenue is less than the operational cost, we would have to again refine our facility financial model. When it comes to storage and packing of seeds, we are still finalizing the best way to store and pack the seeds efficiently. So this remains an open question for the time being, and we would like to address it as we progress.
We learn about our physical farming prototype and how we test this. We have our website, which is a way that connect us with our audience, which kind of visualize what we did and what we do for our project. First, our website have four main parts. There are seagrass farming introduction, which tell people how we farm the seagrass, and we have a deliver method page, which tell them how we deliver our seagrass sustainably, which also can make our more trustworthy, and which means we can deliver the seeds safely and reliably. And then we have a shop page. We are also selling seagrass on our website. And then we have about us page, which tell us who we are and what we do. And here's an example of our homepage. We also have a short animation video tell people why we care about seagrass and why we do this. If you want to watch this, you can go our website and check out this short video. Next slide, please. And since UD and Yasser talk about our farm prototype, how it looks like, I will not take too much time on the farming and deliver page. I will spend more time on our other special sections. For our About Us page, we introduce our team, and we have a special section called Our Story, which record our progress. In this section, we have our story, like how we transform from the previous idea to now the seagrass farm, which shows our process and how we think in this process. Also, we have our second story about our coastal trip, shows how we connect to our stakeholders and how we gain the insight from there and use their insight and the thoughts to build our project better. Next slide. And at last is the most important one, the shop page. And for the shop page, we plan to sell our seagrass. And we have interviewed some stakeholders, and we got our initial thought about our seagrass price, but it's not a super confirmed and super certain number, so we're not putting them on this yet. But we will have we'll know that we'll add them interest. The interest form will be added to allow for the potential customer identification and calculate the willingness to pay the seagrass seeds. So this page still need more time to make it better, but we're planning to not selling seagrass by seeds. We're planning to sell the seagrass seeds by the acres. Like we're selling the whole huge bunches of seagrass together for restoring them. Next. That's all we have. And any questions?
That's so good. That was amazing. Great job. I'm curious. Okay, I'm gonna ask first question. It's like, what is your continued prototyping plan for this? Like, how will you continue testing these things?
Yeah, so our continued prototyping plan is to keep working with the members at the Duke Marine Lab to quantify what materials they need to continue to grow, to build their farm. It is not built yet, but it is under production right now. And to quantify those costs to make sure that they stay under, or find other ways to make them stay under the to make it beneficial for us to sell the seagrass seeds and for the cost of operations to stay under.
Okay, great. You'll continue testing some of the initial hypotheses that you laid out. That's awesome.
Yes.
Great. Okay, Alexis had her hand raised first.
The seagrass farm, the building models that you guys showed, did you guys come up with that, or the Marine Lab has those?
So, yeah, so Christy, who is the lead technician for the seagrass farm at the Duke Marine Lab, had the initial plans set up for us, and we went in there and we developed a 3D model that used the amount of tanks that they had available and the size of the space that they had available, and this is that model that we made.
Got it, great. And so that's how you're able to provide input on the cost, because you're actually doing the
Yes.
real design for them. Okay, great.
Yes,
My other
and we
question,
have all the measurements. Yeah.
Oh,
Yeah.
cool. Go ahead.
Sorry.
Keep going.
Oh yeah, we have all the measurements for all the tanks that they have available, but if it turns out that we are not able to produce the amount of seeds that we want, we're thinking about how much it would cost to add more tanks or to change some of these tanks out to larger tanks so that we can meet our goals.
Cool. Great. Okay, it seemed like one of the biggest market needs was to lower the labor cost of planting seagrass. And if you're just selling the seeds, are you addressing that market need? Or are you going to provide planting services too?
Yes, so the most uncertain and I believe most time consuming part of the seagrass restoration timeline is when they're going out to collect their own seeds. And so it takes them weeks to go out and and sometimes they plan for months ahead of time to do this, and then they go out and the water's too murky or they don't have enough volunteers. And so that is the part that we're addressing.
So the harvesting is the biggest component of the labor. Got it. Great, thanks.
Okay, Helen's up. And just you all did a really great job articulating and quantifying your hypotheses and assumptions.
It's fabulous. I just wanted to put a couple of things in your ear. First of all, we've got Andrew is on the call, and he has done an incredible amount of work with NOAA. He is the driver of the Innovation Lab bus. Again, this is cross-pollination between projects, but Andrew has incredible ocean capacity. I do want to, as a communications person, I really want to emphasize as well the thinking that we can have about bringing in the community. I'm talking with Christy. I believe the lab eventually is supposed to be also an information almost like a museum where people can learn about seagrass and its importance, because the community plays such an important role in keeping seagrass alive and nurturing it. And we'll hear a little bit more about that with the Coastal Connect team. But I do want to also put another piece in your ear that Design Climate and the Duke Marine Lab have been charged with doing some sort of an event early next year. Judy and I have been batting around, what would that be? Would it be on the Duke campus? Would it be at the Marine Lab? And I brought up the question, will it be too soon for people to actually be able to, for high net worth funders who are interested in ocean funding, to come and look at the facilities that are built? These are questions that we'll have to investigate. But I'm thinking about timelines and how we can bring more funding in to make this happen, and think through that as a potential, avenue for raising more funds for this.
Great point.